All right, 6.4, comparing linear and non-linear functions. First problem we have here says complete each table for the sequence of similar rectangles. Graph the data in each table and decide whether each pattern is linear or non-linear. So the first thing we have here is the perimeters. So we have 5 different rectangles. And so what we're going to do is we're going to change the side lengths of each rectangle. For the green rectangle, it has a width of 1 and the length is twice as long. So the length would be 2. If the width is 1 and the length is 2, what does that make the perimeter of the green rectangle? Carson? Makes the perimeter just 6. Yeah, just 6. Yeah, we're plugging 1 in for X. What if we plug 2 in for X? That would move us to the orange rectangle, right? So if 2 is the width and 2x or 4 is the length, then what's the perimeter of that rectangle? Carter?
12.
12. I guess I could have put 1 and 2 right there. For the red rectangle, if we plug in 3 for X and it has a width of 3, its length is going to be twice that. And what would its perimeter be, Sky? 18. Are you seeing a pattern here?
Yes.
Is it a linear pattern?
Yes.
As X increases by 1, Y is increasing by 6. Okay. So we can go ahead and predict the next one's going to be 24. And then for the purple, we can predict 30. Now, we did a problem like this a couple sections ago. But if I write an equation for the perimeter of these rectangles using X's, so in terms of X, it would be X plus 2X plus X plus 2X. Is that correct? All 4 sides? What does that combine to? Xander?
6x.
And that's exactly why we're seeing that every time we input 1 more, it outputs 6 more. Our slope is 6. That's our rate of change. 6x, p equals 6x. So this is linear. This is definitely linear. And go ahead and graph those points then. I want to color code them, but I just don't know if I have the patience for it. So I'll try. This one's going to be, I guess, close to, actually, that's not close to 6. That'd be close to 6. True. I feel like that'd take just as much time, though. So I'm going to say that's about where 12 would be. And then X is 3, Y is 18. So somewhere in that area. And when X is 4, Y is 24. So somewhere there. And when X is 5, I do have the patience, and that's going to be 30. And so if I graph that using a different color, use pink. That looks like it would have to go through the origin. In fact, the equation that I just wrote, P equals 6x, would confirm that it goes to the origin because it's a direct variation and the y-intercept is 0. If you don't have a width, you don't have a length, because 0 width and plugging in 0 for the length, and you wouldn't have a perimeter either. So it would make sense for that. So that one is definitely linear. And so I guess we can write linear somewhere on that graph. Next, we're going to do the same thing, but we're going to calculate the area of these similar triangles. So erasing actually, I don't need to erase anything except for this equation. All right, back to the green rectangle. If I input 1 for X, that means the width is going to be 1 and the length is going to be 2. And what's the area?
2.
2. If I input, you shut the door for me, Connor. If I input 2 for X, we know that makes the length 4. And what's the area of that orange rectangle then? Person? 8. Now I'm going to have to see 3 numbers to predict, see if there's a pattern, right? Because right now I can say, oh, it's just increasing by 6 again. If I plug in 3, that means my width is 3, my length is 6. What's the area of the red rectangle? Alex? 18. So already I'm seeing this is not linear. It increased by 6, then it increased by 10. If I plug in 4, 4 would be my width. 8 would be my length. What's 4 times 8? Deegan? 32. If I plug in 5, the width becomes 5, the length becomes 10. What's 10 times 5?
50.
50.
Obvious.
So this one's obviously not linear. Go ahead and plot the points and we'll see what this looks like. Give your best estimate as to what you think, where you think the points would be. Oops, start at 1. A little bit more difficult when they're counting by, well, actually, no, they're still counting by 5s. Never mind. They're still counting by 5s. That's about 2. Next one's 2, 8. Right there. Area 318. Somewhere in this area. 432. Somewhere there. And then 550. An actual point that meets at a nice spot all the way up here. And if I graph this one, we're going to see it again starting at the origin. It's going to have to start there because if I don't have a width, I don't have an area. It looks like that. That is half of a parabola. And a parabola is the kind of graph you'll get when you graph a x squared function. And so that's because when we are finding the area, remember we said when we did our other chapter with similar figures, we said that when you're talking about the perimeter ratio equals the side length ratio. There's no change. But the area ratio is the square of the side length ratio, which is why we're seeing this exponential, this parabola, because of the exponent, next to the I should say the exponent of 2, the squared exponent next to our x. So this would be p or a. Actually, we might use not use the p. We'll use a for area. A equals, and then I can't just put x squared because that's not necessarily true. Because if it were x squared, then when I input 1, I'd output 1. And when I input 2, I'd output 4. When I input 3, I'd output 9. When I input 4, I'd output 16. So is there something else that's being, well, let's see. Last time I wrote out the perimeter function as p equals x plus 2x plus x plus 2x. This time, let me write out as a equals x times 2x. What do you think you'll get when you multiply x and 2x together? Lizzie? 2x squared. So there's a 2 in front of my x squared. So when I input 1, it's going to square it to get 1 and then times by 2. That makes sense. When I input 2, it's going to square it to get 4 and then times by 2, it's going to output 8. When I input 3, I'm going to get 9 when I square, and then times by 2 gives me 18. So this does make sense. And this one is definitely nonlinear. So when I'm looking at a graph, it's pretty obvious to see what's linear and what's nonlinear. When I'm looking at a chart, one that's filled in at least, I had to fill this one in ourselves. When I'm looking at a chart, I'm looking to see if my rise and my rise and run are constant or if they're variable. Variable isn't just a word we use for X, Y, Z. It means it's always changing. If something's variable, it means it's always changing. And so the graph of a linear function shows a constant rate of change. That means it's going to have a slope, right? Have that constant slope. A nonlinear function has a variable rate of change, so its graph is not a line. Some sort of curve. Could be a parabola, like this half a line we see here, or half a curve here as part of a parabola. It may not be a parabola. Maybe you're doing something to the third power, x to the third power, fourth power. Look at this next example. We have a parachuter and a bowling ball. Now I want you to imagine pulling your parachute string when you're falling from the sky and dropping a bowling ball from the top of the Hoover Dam. Which one do you think is going to be linear? Which one's going to give you that constant speed? Deegan? The bowling balls falling at the same rate? Okay, hold on. As soon as I pull the parachute. When I pull the parachute, regardless how fast I was going before I pulled the parachute, which I see your confusion there. As soon as I pull that parachute, it's going to slow me down and I'm going to be floating down to the ground at that same speed. Whereas if I drop a bowling ball, it's going to pick up speed. Okay. I want you to imagine if you were laying on the ground and I put the bowling ball 1 centimeter from your forehead and dropped it on you. It would hurt, right? Now I'm going to hold it 10 feet over your head and drop it on you. It hurts the same, right?
No, that can kill you.
Because it's going to pick up speed, right? And that's the difference between a parachute and then obviously a bowling ball without a parachute. Or the same for anything, right? Now, eventually, I don't know how much you guys have talked about this or not, but that bowling ball would reach terminal velocity, which means it's not going to increase speed anymore. It's reached its maximum speed as falling to the ground. But until it gets there, it's going to exponentially get faster and faster and faster until it reaches that terminal velocity. Yes, Shane? No, okay. So we're going to graph these two different outcomes here. When I input 0, so when I pull my parachute at 0 seconds, I am 300 feet from the ground. This graph is on the y-axis counting by 30s. So 300 is going to be up here at the very top. So I've just pulled my parachute. I'm 300 feet up in the air. 1 second later, because I'm counting in seconds. 1 second later, my height is now 285. So if this is 270, then 285 would be, and that's 300 there. And at 3 seconds, 2 seconds, I skipped one. I'm at 270, so I'm here. And at 3 seconds, I'm at 255. So I'm here, halfway between 240 and 270, because I'm going 15 feet every second. And then at 4 seconds, I'm at 240, and you get the idea. I can draw a line because this is linear, and wherever that line crosses the x-axis, which isn't going to be on our graph, but wherever that line crosses the x-axis is going to tell us how many seconds before, or how many seconds it will take for us to hit the ground. Because when the x-axis, when we get that x-axis, we'll be on the ground. So our speed right now is 15 feet per second, but we are falling. So how should we write that speed? Xander?
-15.
That's right. So I could write a linear function, y equals -15 feet per second, or -15x. And what am I starting at? Go ahead and finish it.
300.
Yep, plus 300. If it's linear, you can write a slope-intercept equation, because you can write slope-intercept form for all linear functions. Now, we could also have showed that it was linear because you're always decreasing 15 every single time your x increases by 1, your y is decreasing 15. So we can also see using the chart that it's linear. The bowling ball, as you might suspect, is not going to be linear. It's decreasing 16, and then it's decreasing 22. I check the math on that. 284 minus 236. Whoa, what? I was way off. 48. Whoops. And then 236 minus 156 is 80. So it's picking up every second that goes by. It's not constant. It's variable. So if I graph these points, we'll see what this looks like. The bowling ball is being dropped from 300 feet in the air, just like the parachuter. Now, I hope that you don't pull your parachute cord when you're 300 feet in the air. Typically, you want to do that way, way higher. I don't know much about parachuting or anything like that, but typically you would pull that way before you get to 300 feet. 300 feet is the length of the football field. You're like a second from the impact at that point. Okay, until you pull it. So pull it before that.
That's why you pull it that way. It's funner.
from a wild side.
Yeah. Now, what's interesting is that the parachuter and the bowling ball are actually pretty close 1 second in. Parachuter's at 285, bowling ball is at 284. So right around that area still. It's second 2, 3, and 4, seconds 2, 3, and 4, where you start to see that big difference. At 2 seconds, we're at 236. 236. So this is 210. 236 is going to put us close to there, just before 240. And then at 3 seconds, we're at 156. So this is 150. 156 would be somewhere close to or just after 150. And then at 4 seconds, we're at 44 feet. So if this is 30, 44 would be almost halfway between. And so what we see here is an inverted half a parabola. So the way that we would describe this, we would say that as time is increasing, your height is decreasing, but not at a constant rate. It's decreasing at an increasing rate. It's decreasing at an increasing rate. Does that make sense? Okay, it's decreasing, and the rate that it's decreasing is increasing. Yes, until it hits that terminal velocity, but at 300 feet, it won't hit that terminal velocity. It's just going to hit the ground really hard. Okay? And yes, you would die if you were 300 feet above the bowling ball. So yeah,
I'll
it's
die at probably like
if you're 300 feet below the bowling ball, or above it, you're going to die anyways. So if you're 600 feet in the air without a parachute, yes, you're going to die. Okay, now let's look at a mixture of charts or tables, what do you want to call them, and graphs, and see if we can determine if it's linear or nonlinear. Explain by showing your work if you're looking at the table. So on this table, as y increases by 9, x is increasing by 2. And then as y increases by, this is where I need you to step in. As y increases by 22, x increases by 2. That's not the same rate. Now, the reason I'm starting with y is because I like to start with y so I don't forget it's rise over run, not run over rise. But either way, you can see this is non-linear. I'm just going to put NL for non-linear because that rate of change is not constant. What about the graph of B? Linear or non-linear? Sky? Non-linear. Yes, easy to see at a graph. This is actually a variation of the, let's see, I should get one. So it's not exact, but it's a variation. It's a sibling function of the f of x equals x cubed function. An x cubed function will have some sort of form of this. Now I know it's not exactly x cubed, because if it were x cubed, then if I plug in 1, if I input 1, it should output 1 times 1 times 1, which is 1. And this is outputting like a fourth, maybe? I'm not sure exactly what that is. So we're noticing that not exactly the parent x to the third function, but it's a variation of that function. What about this one here? Linear or non-linear? Linear. On your homework tonight, instead of putting a bunch of n's, l's, and l's, every time you get to a linear function, I want you to write that linear function's slope-intercept equation, either using f of x or y, your choice. What's the slope of this function? Maddox? You're right. So numerically 0, correct? So then I don't need to put 0x. That's just a waste. What's the y-intercept, Maddox? So you can either write f of x equals -2 or y equals -2, your choice. But I do want you to write all the functions that are linear in slope-intercept form. Julia? You didn't, on your work paper, you didn't do that? I will unsubmit yours. Anybody else need me to unsubmit theirs? I'm just going to unsubmit everybody's. So sorry if you already did it. I'll turn it back in for you in 2 days if it makes that big of a deal to you, or you can turn it in yourself. Okay, and I believe that note is on there. For those of you who haven't started yet, I believe there's a note that says that, but not everybody reads those notes because sometimes those notes say no work paper, and this one said something else. For example, D, let's check the rise and run. What's happening with our Y values? We go down this chart, Lucy. Subtracting 5. The run is adding 7. Do it again. Y value is good. Subtracting 5 again. And one more time, just in case, we still see this -5 plus 7. So we know this is linear. So there's my L for linear. Did I do that last time? I did. Okay. There's my L for linear, and the slope intercept function or slope intercept equation. I'll do this one with Y equals. So I'm not showing partiality. The slope is rise over run. So what is the slope? I have it up here on the notes. We just have to write as a fraction. Xander?
-5/7.
That's right, -5/7. Okay. Rise -5, run 7. So the slope is -5/7. Don't forget your X. And then we need our Y-intercept. Do they give us the Y-intercept? They give us X being 0. And when X is 0, Y is 25. So there's our equation. So if it's linear, write the slope intercept equation like you guys did on the quiz and like I'm going to have you do on Friday's test. All right. This function, linear or nonlinear? Is it made up of lines?
Yes.
Is it one line?
No.
No, it's nonlinear. I see your hesitation, but it is nonlinear. The slope changes. The slope goes from a positive slope to a negative slope. Therefore, it can't be a constant slope. So it is nonlinear. Now, this is a variation of the absolute value function. When you take the absolute value of a number, it will never be negative. So for example, if I take the absolute value of 0, it's 0. If I take the absolute value of 1, it's 1. Absolute value of 2 is 2. Absolute value of -1, still 1. Absolute value of -2, 2. And so this V is the parent function of the absolute value function. So what we have here is it's been inverted. So they put and you'll learn all about this next year in Algebra 1. They put a negative in front, not inside, because that wouldn't matter. So positive, you put it inside the absolute value. If you put the negative outside, it's going to flip the V upside down. And this V, I would say, is a little skinnier than the V I drew. So they probably have multiplied it by a factor of 2. Yes, it looks like they did. And instead of starting at 0, they started it up here. So then I would put +2. So we're probably looking at this function. That's probably how I would write it, with just some basic observations. The +2 means that you're not starting at 0, you elevated that up 2, and then we inverted it. So there's the negative, and then we times it by 2, and that's going to make it skin. Same thing happens when you have a line. This is X. This is Y equals X. This is Y equals 2X. This is Y equals 3X, 4X. But it's just going to get the larger the slope, the steeper the line. All right. Example F. Rise what? Jacoby? Is the rise always the same, Jacoby? Oh, it's not. But before you guys jump to conclusions, look at the run. +2, +2, +1. Is the slope of -4/2 the same as -2/1? So this is constant. This is linear. Even though we went from changing by -4 to -2, we also went from changing by 2 to 1 in this particular one. So this is a constant rate of change. And we just said the slope there is going to be -2/1 or just -2. Y equals -2x plus something. And so do they give us the Y-intercept? Where do you see X being 0? They don't give it to us. However, yeah, they give us the X-intercept. You're right. This is the X-intercept right here, which I don't want. But it wouldn't be too difficult to reverse this. Subtract 2, give us 0 for x, and add 4, remember I'm inverting it, reversing it, and giving us what? Sky? 12. So we can make a pretty good assumption that we're going to have a y-intercept of 12. So negative 2x plus 12. Also, since I was asked this a lot on the 6.3 homework, there was a particular question you remember that had I think I did it in class yesterday, it had the chart that didn't give us the y-intercept. When in doubt, use point slope form. Take your slope, plug it into this equation. So plug the slope in, take one of the points on the chart, plug it in there, and then solve for y, and you'll have your slope intercept equation. So when in doubt, you can always use that. Decide whether the function is linear or nonlinear by looking at its equation. Y equals 4.7, linear or nonlinear? Martin, thanks for volunteering. That is true. Why? Yeah, you're exactly right. It's a horizontal line. You could also say y equals 0x plus 4.7. It has a slope of 0. It crosses the y-axis 4.7. It's still a line. Good. Y equals pi x. Sky?
Linear.
It is linear. Yeah, pi is a number, just like any other number. And so it's the m value. So the slope is pi. The b value is 0. It just means it crosses at the origin, but this is still linear. Yeah, good job. So I guess we could say if the x isn't there, that's because it was raised to the 0 power. If the x is there and it's raised to the first power, it's still good. In fact, most often times the x is there and we're good. If x is raised to the second, third, fourth, fifth, anything other than 1 or 0, which means it's gone. If it's raised anything other than that, it's going to be nonlinear. So what do you think about this one? Linear or nonlinear? Xander?
Non-linear.
It is nonlinear. That's because this 2 divided by x could be rewritten as 2x to the negative first power. When you raise a number to a negative power, you're dividing. And that does not work. It won't be linear. Okay, and we'll actually talk about negative exponents in 2 chapters from now. Not sure well it looked at the time. Like here in the next 5 months, we'll be talking about that. No, just kidding. We'll talk about it here in the next couple chapters. What about this one? Linear, nonlinear? Dawson, what do you think? Nonlinear. Why? Is it okay to have a plus or minus after the x? What about y equals 2x plus 6? Is that linear? Okay. So not a good reason. Let me have you do something real quick. Can you take the 4 that's in front of the parentheses and distribute it to the terms inside? What would you get? Is that linear? It is linear. Yes, this is going to be linear. Yeah, the parentheses might have thrown us off there, but yes, this is going to be linear. It was not written in slope intercept form, but it could be. It could be. What about this next one? Y equals 4x over 3. Jimmy, what do you think? Linear is correct. Nice job. The difference between this problem and the one above it is that the x is located on top, which is where it needs to be. Has anyone typed an answer into Big Ideas and you accidentally had the x on the bottom of the fraction, so it was wrong? Sometimes when you're typing in your slope fraction, if you don't click the cursor to get it back up there and you put the x on the bottom of the fraction and say it's wrong, that's because your x would have a negative exponent if you left it there. This x, however, is on the top. In fact, I could also write this as 4/3 x, which is perfectly legal. In fact, I would normally write it that way. The slope is 4/3. And so this is going to be just a direct variation. It's going to have a y-intercept of 0 and a slope of 4/3. What about example F? Linear or nonlinear? Sorry. Oliver? Gosh, Owen this is my name for everybody now. If I look at you and I say Owen, just know that I'm actually talking to you and not Owen. Apparently I do all the time. Oliver, nonlinear, why? Exactly right. Yeah, some sort of parabola form. At least I'm not calling any girls Owen. Not yet. Yeah, challenge accepted. Example, next one says account A earns simple interest, account B earns compound interest. Now, we'll talk about the simple interest formula. I wish we would have had an opportunity to do that in our practice test, but they didn't actually use the simple interest formula. But simple interest is different from compound interest. What do you notice the difference between simple interest and compound interest? If A is simple and B is compound, and you're looking at their balances, what can you say about the simple interest formula? Brady? It's linear. Yeah, simple interest is actually linear. Compound interest is not. Simple interest is what your house mortgage loan is going to be. Your car loan will be simple interest. Credit cards, this is why people get in trouble with credit cards, use compound interest. So if you don't pay off your credit card bill, it's going to escalate much more quickly than what missing a payment on your mortgage would do. Yeah, so B is definitely nonlinear. Compound interest is nonlinear. All right, I've got a question from our homework in here. We can look at number 18 and then I'll pass back your guys' quizzes. We get out at 40, I believe, right? Yes, okay. So number 18 and the homework says the ordered pairs represent a function 0, -1, 1, 0, 2, 3, 3, 8, and 4, 15. Go ahead and plot them, even right now in the notes. Just go ahead and plot them right there in the notes. Every year I'm asked about this one, so I just went ahead and put it in the homework. I may not know the equation of this function, but it's safe to say what about it? Xander? It is half a parabola. What else? In terms of what we've been talking about here, Lucy? Definitely nonlinear. Half a parabola. So it's probably gonna have an x squared as part of it. Okay. So after I graph it, it says as x increases by blank, which it looks like it just increases by 1 each time, y increases by blank more than the previous. Okay, so let's see what we're looking at here. Let's see what the y's are increasing by. This y increased by 1. This one increased by 3. This one increased by 3 to 8. 5. Thank you. Next up, 8 to 7 or 8 to 15 increases by 7. Darn it. So as the x increases by 1, the y is increasing by different amounts. We know it's nonlinear, but it's how many more than the previous increase, Guy? It's 2 more than the previous increase. And so then it wants you to write, so the graph is nonlinear. We already know that. Oops, and L, nonlinear. So it wants us to write the equation. Now it's going to have an x squared in it. So Xander's right. It is half a parabola. The question is anything being multiplied, added, or subtracted to the x squared? What do you think, Sky? -1. Okay, let's see if her function works. According to Sky's function, if I plug in 0 for x, 0 squared minus 1 should give me -1. That one checks out. If I plug in 1 for x, 1 squared is 1, 1 minus 1 is 0. 1, 0 works. If I plug in 2 for x, 2 squared is 4. 4 minus 1 is 3. If I plug in 4 for x, 4 squared is, I skipped 3 for some reason, but whatever. If I plug in 4, 4 squared is 16, and 16 minus 1 is 15. That one works. You're exactly right. That is the correct function. So the parent function is the y equals x squared, and then what they did by subtracting 1 is just lowering everything down by 1. Yep. So instead of starting at the origin, it starts at 1 point lower than the origin. Yes. On 16 as well. Let me go ahead and stop recording. We can look at that.